Hey Year 12, so for this lesson, lesson 5, we are building on the previous lesson where we learnt about scatterplots, but now we're going to learn how to interpret them. Firstly, we're going to focus on 3 things that we look for in a scatterplot, that being direction and outliers, that counts as sort of one dot point, form and strength. Okay, so in terms of direction of an association, we look at this first picture here, we can see that there is an increasing trend, okay? So as these values go up, then these values go up. As we remember from the previous lesson, the ones at the bottom is the explanatory variable, and the ones on the up and down vertical scale is the response variable. So if they're both moving up from left to right, then we say that there is a positive association between the variable. The explanatory variable and the response variable together go up. Just like in the next one, as you can see, they're both going down. So if the points in the scatterplot go down, as we go from left to right, then we say that there is a negative association. And if there is no clear pattern in the scatterplot, that is, the points just seem to be randomly appearing anywhere, then we say that there is no association. Okay, let's look at some examples. So classify each of the following as positive, negative, or no association. This one here, we can see that the direction of the association is positive. So how do we make sense of this in terms of what the actual variables are? So students who spend more time on the exam tend to get higher marks. Okay, so as this goes up, this also goes up. For this one here, we can see that there is a negative association. The price of a car tends to decrease with age. So there's a different way of saying it, but essentially, as age goes down, the price goes down. So that's just sort of written backwards, but still says the same thing. What we want to say is, as age goes down, price goes down. Sorry, as age goes up, price goes down. Here we have what look like no association, because there's no clear pattern, no association between calf diameter and age. So we can't really say a statement there. We just say there's no association between calf diameter and age. Form. Okay, so when we say form, the points in the scatterplot tend to follow a linear pattern or a curved pattern. Here, this one is what we call a linear pattern, because it is, the points in the scatterplot tend to follow a straight line. Whereas here, we say that there is a non-linear pattern. Okay, curved is just the everyday word, but the fancy word, or the real word that we're looking for here, is non-linear. That's because we use a curved line. We see a curved line. Okay, so it's important that when we talk about the association, we use these words. If we're going to explain why, well, then we might use these words. So, classify the form of the association in each of the following scatterplots as either linear or non-linear. Here we see that the direction of this is going sort of in a straight line. So there is a clear straight line here. So that means that the association is linear. Here there is like a curved line, as you can see, clear curved pattern. So that means it is non-linear association. So far we've looked at, this was form, when we talk about curved or not curved, linear or not linear. And we talked about direction, which is positive, negative, or no association. But now we want to talk about the last one, which is strength. Okay, so These are all positive sort of directions, apart from that last one, which has no association. But it's either strong, moderate, or weak. Okay, so this one here is a strong association. This one here would be a medium or a moderate. Moderate's probably the word to use, association. This one here would be weak. Okay, it's a bit more variable, so it's a weak association. And lastly, this one has no trend or no relationship, so the way to say it is no association. Cool. So we can comment on two of those things together. We can talk about the strength and the direction. So here we can say that this is a strong positive association. I'm just going to talk these through and then I'll put up the answers. So this second one here looks like it's still going up, so it's positive, but it's like a moderate version. So we can say this is a moderate positive association. And this one still, you can sort of see that it's going up. It does almost look like there's no trend, but we can sort of see a positive association. So we say that this is a weak positive association. This one down here, okay, it's going downwards and it's strong. Looks like nice and close together. So that would be a strong negative association. This one would be still going down, a moderate negative association. And this one, although it looks like there's no trend, you can still see some sort of direction in it. And it's going down, but it's a weak negative association. Okay, and as you can see there, those are the answers. So please copy those down. We can now talk about all three combined. Okay, so again, I'm not going to write them, but I'll fill them in a second. Let's see what's going on here. This one is going up, so it's positive. It looks relatively close together, all the dots, so it looks strong. And it looks like it's a straight line. So this here would be a strong positive linear association. This one here looks like it's going up. Doesn't really look curved, but it looks like it's a moderate in strength. So we can say moderate linear, moderate positive linear association. And this one here obviously being a weak positive linear association. Here we can see that it's a strong relationship, but we do see a little bit of a curve. So this one would be a strong positive non-linear association. This one looks like a moderate positive non-linear association. Too many fancy words for me. And this one here is a weak positive non-linear association. Okay, so please just copy those down. Alright, and when we talk about the strength of a linear relationship, we also want to measure it. So we want to talk about how strong is it. Okay, so here we just sort of used our imagination. We say, yeah, that's strong, but is it strong or is it moderate? Like, where do we draw the line? Okay, so where do we say this is strong and this is moderate? We actually have a number that's going to talk about how strong it needs to be, how close the dots need to be together to be considered strong, or how close they need to be, or how far apart they need to be considered moderate, and same for weak. We also have a number that tells us, well, there's no real association, so it must be no association. So that's what we're going to learn, and that's called the correlation coefficient. Okay, so first things first, when an association is linear, which is a straight line, the most commonly used measure of strength of the relationship is the Pearson's correlation coefficient. Okay, which is essentially this thing here that we just spoke about. So there are two key assumptions that when we use this coefficient, that the data is numerical, okay, not categorical obviously, has to be numerical, and that the association is linear. We just learnt about linear, so that the dots are going in a straight line direction as opposed to curve. So this one here is if we're to talk about, those three things that we just mentioned on the previous page, this one would have no association. So we don't know if it's positive, we don't think it's positive, we don't think it's negative. We don't really know if it's, we can't really tell if it's positive or negative. We can't really tell the strength because it seems really, really weak. So therefore we just write no association. This one here is what we call the perfect positive linear association. Okay, it's similar to strong, but it's even stronger than strong. It's perfect. It's literally a straight line. Okay, so that's why we call it perfect. Same thing with this one. This is also perfect, but instead of being positive, it's a negative linear association. Can't spell today. So, if there is something that has no association, well, we're going to say that this R value is 0. Now, I did say R. R is the word that we use. So, for up here, okay, R is our correlation coefficient. Okay, so rather than writing Pearson correlation coefficient is 0, we just say R is 0. If we say that something's perfectly positive, we say that the R value is 1. And if we say that the relationship or the association is perfectly negative, then we have an R value of -1. So what we need to think about is that the two extremes of a linear association are when it's perfectly positive and when it's perfectly negative. Everything else is something in between, including no association, which is 0. Okay, so the worst association is probably 0 because there's just dots everywhere. It means nothing to us. Okay, we want to have an R value as close as possible to R equals 1 or R equals -1, so we can help understand what the trend is of this data. So when we want to use the guidelines, a perfect positive linear association is when R equals 1, and a perfect negative association is when R equals -1. So, what classifies as a strong positive linear association? So, going back, that's when we're talking about these things. This is strong. This is strong. So, how do we actually know what the R value needs to be for us to call it strong? Well, the R value needs to be between 0.75 and 0.99. Okay, so what about moderate? And last but not least, a strong negative linear association is between -0.75 and -0.99. What I'll do here, and I'm sorry about how the letters kept going underneath the line, that's very frustrating, but we can see that strong is 0.75 and 0.99. Strong is between -0.75 and -0.99. So they're the same, but just positive and negative. Same thing with moderate. Okay, 0.5, 0.74. -0.5, -0.4. And same with weak. Between 0.25 and 0.49, and -0.25 and -0.49. Okay, so it's the same, it matches. Okay, the only thing that's different is the two perfect ones, which again, well, they do match as well. Okay, 1 and -1 for perfect and perfect. And then the no linear association is everything in between. So let's use that table, that can go into your summary books, to help us to practice using the values of R to sort of talk about what shape it is, or what strength it is. Here, the actual R value of this number here is positive 0.915. Okay, so this here is a strong positive because it falls under the strong section. Here we have positive 0.767. So 0.767 to me, still falls in that strong group. And because it's positive, we say strong positive again. Here we have 0.551. That's a positive number. 0.551 is in the green. Okay, it's in this section here. So we say that that is moderate positive. Okay, and so on. So now that we're dealing with the negative numbers, negative 0.874, okay, falls in the yellow group here. Okay, so it's strong negative. This one here would be moderate negative. And lastly, this here is negative 0.150. Okay, so where does that fall in this group? That falls in this section here, which means no association. No linear association. No linear association. Awesome. Alright, so let's now practice using our CAS to calculate the R value. So how did we actually get these R values? Alright, so what we can do is we can create a scatter plot like this and then actually get this R value, so then we can get the descriptive word for it. Okay, so open up your calculators. Okay, once you've done that, go into list and spreadsheets, and here we have the data for marks of 10 students and the time they spent studying for the exam. So use time as the explanatory variable. Hopefully we want to analyze to see whether time spent studying explains marks as the response variable. So let's write in time in here, let's write in mark in here, and let's put in our numbers. Alright, so once I've put in all the numbers, I say this every single time, but please remember to scroll all the way up to the top once you've completed it, so that way you can register all the numbers. Next step says press Ctrl I to add calculator, and then once you've done that, press the following buttons: menu, statistics, stat calculations, linear regression, A plus BX. Hopefully you remember this from last year. We want to now identify our response variable and our explanatory variable. So what you want in your X list is your explanatory variable. Okay, in this case it's time. So hopefully time explains the mark. We press OK. This is going to give us all the numbers that we need in order to analyze this. We're going to later look at the A, the B values, but what we just care about for this lesson here is the R value. In this case, we got an R value of 0.944. Okay, that's our correlation coefficient. So let's look back up to our notes. Where does 0.944 go? That is a strong positive linear association. Okay, so that's a quick way of getting the R values. Okay, so let's go now and complete the questions that we need to. There is 2 exercises you need to complete, but not many questions from each. So you will need to complete exercise 2E, questions 1 and 2, and exercise 2F, 1, 2, and 3AB. Thank you very much.